Hello everyone. In last session we have studied about convolutional neural network. Hope that you may aware about it. So, in order to process the image related task, we are preferably go for convolutional neural network, right? So we know the convolutional neural network one of the most important algorithm for our image processing. And with that, we have already studied what is it contain. Now, for this session, what we are going to learn is uh, how to work with pooling operations, and how to calculate the number of future maps are expected based on the given information related to the convolutional network. Okay. Now, these are the fundamentals that you may aware of already. We have already studied this one, right? Pooling layer is reduces the size of that particular features, where we can use three type of pooling. One is max pooling, main pooling, and edge pooling. And flattening is converting the two-dimensional matrix into only vector. These are the key terms that we must know before entering into that particular topic. Okay. So just recollect all those things, and we are move on to the uh, process now. Let us assume that is an image. The image is 3 cross 3. So you can see this one, right? Yeah, I will highlight it. You can see this one. The image is actually 3 cross 3. It contains the pixel intensity values 1, 2, 3, 4, 5, 6, and 7, 8, 9. So once, if you are needed to add the padding, remember the padding that we have already discussed, right? The padding is adding the corner values. Now, all the four corners have added with 0. Now the padding with 0, the padding size is 1. So one layer of padding has been added over there out of that particular image. So outside the in the image pixel intensities, one layer on the left, one layer on the right, one layer on the top and bottom have been added with zeros, padding with zeros. Now the image has become 5 cross 5. Okay? And then if you need to apply the max pooling, what you need to do, a pool size will be given. So what is actually the pool size? Pool size is nothing but its contain a kernel. The kernel size is 2 cross 2. That kernel will operate on that particular image. Let us assume the pool size is 2 cross 2. So what will be taken here? A 2 cross 2 matrix will be taken here from the image. Let us assume this one. Okay. This is the first 2 cross 2 one. Okay. 1 comma 2 and 4 comma 5 is taken. So what is the pooling is? Apply the max pooling. What's the max pooling is? So we need to choose the maximum value out of this two. So like we have to choose the second pool, okay, and third pool. This is called as future map. So how many for this 4 cross 4? How many values can be taken? How many future maps can be taken? 1, 2, 3. Okay, this operation has to be applied on the original image. Okay, now it is an output. I will show how to apply it on original image. Okay, the original images looks like this, right? So we have to choose the future maps based on the pool kernel. What's the pool kernel here? 0, 0, 0, 1. This is the first pool kernel. What's the maximum value out of it? 1. And second pool kernel is this one, 0, 0, 1, 2. So what's the maximum value against it? 2. And what's the third pool kernel is? Full future map is this one. So what's the maximum value out of it? 3. And the final one is this one. Okay, what's the maximum value out of it? 3. This is the first row value. Likewise, the second pool future map has to be taken 0, 0, 0, 1, 0, 4. This has to be taken. Out of this, the 4 will be the second largest one. Okay, look at this one. Now you can see this result 4. Okay, this. Similarly, you have to move on to further future maps 1, 2, 4, 5. Like you have to choose all the future maps which can reduce the image 5, 5 to 4 cross 4. Your original image is 5, 5 and your output image is 4, 4, which reduces the future. In that aspect, the pooling operations are reducing the futures. Right? Hope it is clear. There are three types of pooling operations are possible. One is max pooling, that we have applied max pooling on 2 cross 2 window. We choosing the maximum value, right? 2 cross 2 window, we choosing the maximum value. In case if it is a minimum pooling, we need to choose the min value. And in case if it is an average pooling, what we have to do is we have to take the average of all these four values. What will be the result then? 1 plus 2, 3, 3 plus 4, 7, 7 plus 5, 12. 12 divided by 4 equal to 3. 3 will be the average pooling power. Like you have to apply the pooling operations on the convolutional neural network in order to reduce the future map size. Hope it is clear. Now let's move on to another thing. How many future maps are possible? How many future maps are possible when we are applying the convolutional operation? So let us explore this particular question. The CNN layer receives an input image of size 32 cross 32. So your input size is 32 cross 32. Okay, how many pixels will be there on the row wise? 32 pixels are there, on the column wise 32 pixels are there. Okay, approximately it is around 900 pixels are there in an image, right? Then it applies 8 filters. How many filters? You can see this one, 8 filters. How many filters we are using? Number of filters is 8. Each filter contains the size 3 cross 3. So what is filter? That already we have studied clearly, right? The filter is nothing but a simple matrix, simple numerical matrix, maybe contain 2 cross 2, 3 cross 3, 4 cross 4, or n cross n dimension, right? Which will be sliding over that image and will apply some operations based on the result will be displayed, right? So this is what the filter is do. Okay. Now, so how many filters we are using is 8 type of filter. Let us assume it is a 2 cross 2 filter. 1, 0, and 0, 1. It could be one filter. Okay. And second filter is like this. -1, 0, 0, -1. Like is another filter. Similarly, the another filter may be 1, 1, 0, 0. Okay, and another filter may be 0, 0, 1, 1. Right? So there are 4 type of filters here. Similarly, there are 8 type of filters is applied on this 32 cross 32 image, right? Now, so what is the size of the filter? Each filter is a size 3 cross 3 and stride. As we know, the stride is how many number of pixels we need to slide. Okay, how many number of pixels we need to. The stride, since the stride is 1, what we have done earlier is, so we took, this is a first feature map, right? We took this is the first feature map. So if stride is 1, the second feature map will start from the next column itself. Okay. If stride is 2, what we will do, the next feature map will be started from, okay, let us assume this is the first feature map and stride is 2. What you will do, you have started from this column, you need to skip this column and you have to start the second feature map from this one. Okay. The second column has to be dropped. Okay, I hope it is clear. So now we have to apply this particular thing. So what is the formula for identifying the future map is total number of input dimension, the input size of the image, and F is filter size, and P is padding. So they have mentioned there is no padding, you have to apply 0, and S is stride. So the formula is n minus f plus 2p divided by S plus 1 you have to apply. Okay, look at this one. Now the output size is 32 is your dimension, 3 is your kernel, and 0 is your padding, and 1 is your stride, and plus 1 is in formula. So you have applied this and you got 30. So when you are giving 32 cross 32 image and 3 cross 3 filters, total 8 filters. So how many filters we are using? 8 filters. What is the input and output dimension is 30. The final image you will get is 30 cross 30 into 8 dimension. Okay, this is what the output of the final feature map. The aspects you have to work on it. I hope that you may clear about it. So if you have any issues, please let us know. We will discuss.